Gradation in properties. Gradation in properties. Okay, first the ionization potential, electronegativity character, the melting point, the boiling point gradually decreases with increase in atomic weight number of. Okay, gradation properties of group of 14 group of 14 elements, group 14 elements. Okay, first point, the ionization potential. The ionization potential, electronegativity character, electro electronegativity character. Gradation in properties. Gradation in properties of group 14 elements. Okay, first point, the ionization potential. The ionization potential, electronegativity character, and melting point and boiling point. The melting point and boiling point gradually decreases. Gradually decreases. Okay, gradually decreases with the increase in atomic weight. With the increase in atomic weight. In atomic weight. Okay, in atomic weight number. Okay, the ionization potential, electronegativity character, the melting point, the boiling point gradually decreases with the increase in atomic weight. Okay, second point, the atomic volume, electropositive character, metallic character gradually increase with the increase in atomic weight. Okay, the atomic value, electropositive character, electropositive character, the atomic value, electropositive character, metallic character, gradually increase with the increase in atomic weight. Increase with the increase in atomic weight. Okay, atomic weight. Third point, the non-metallic character also changes to metallic character as we move down the group. Thus, carbon and silicon are non-metals, germanium is a metallide, and tin and lead are metals. Okay, the non-metallic character also changes. The non-metallic character also changes. The non-metallic character also changes. To metallic character. To metallic character. Now, the non-metallic character also changes metallic character as we move down the group. As we move down the group. Thus, carbon and silicon are non-metals. Thus, carbon and silicon are non-metals. Carbon and silicon are non-metals. Germanium is metallite. 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 Tin and lead are metals. Tin and lead are metals. Okay. Fourth point. The stability of hydrides decreases with the increase in atomic number. The stability of hydrides decreases with the increase in the stability of hydrides decreases with the increase in atomic number. Okay. The stability of hydrides decreases. The stability of hydrides decreases with the increase in atomic numbers. 5 point. The stability of chlorides also decreases with the increase in atomic numbers. The stability of chlorides also decreases with the stability of chloride also decreases with the increase in atomic number. With the increase decreases with the increase atomic number. With the increase in atomic number. Increase in atomic number. Okay. With the increase in atomic number. Carbon from chloroform. CHCl3 chloroform and silicon forms silica. Silicon forms silica. Silicon and silicon forms silicochloroform. SiHCl3 silicochloroform. 6 point. The acidity of oxide decreases from carbon to lead. Okay. The acidity of oxides decreases the acidity of oxides decreases. The acidity of oxides decreases from carbon to lead. From carbon to lead. Carbon dioxide is acidic. Carbon dioxide is acidic. Silicon dioxide is weakly acidic. Silicon dioxide is weakly acidic. And SnO2, stainless oxide, and lead oxide are amphoteric, and lead oxide PbO2, lead oxide, lead carbon dioxide, lead dioxide are amphoteric, amphoteric. 7 point. Catenation property also decreases. Catenation properties also decreases. Catenation properties also decreases on moving down the group. On moving down the moving down the group, okay. Catenation properties also decreases on moving down the group. Carbon has maximum property of forming chains. Carbon has maximum carbon has maximum properties. Carbon has maximum properties of forming chains, okay. Carbon property has a maximum carbon property of forming chains and ring by self-linking, and ring by self-linking but silicon has a limited extent. Silicon has a limited extent, of self catenation okay. Then hence we see that there is a regular gradation in the property of group 14 elements with the increase of atomic weight, okay. Anomalous behavior of carbon. Anomalous behavior of carbon. Due to small size, high electronegativity of chains of d orbital, the first member of the group 14 carbon differs from other members of the group in the following ways. First point. Maximum covalency of carbon is 4. Maximum covalency of carbon is 4. For other it is 6. For other it is 6. Other it is 6. Okay. Other it is 6. Okay. And carbon has 4 electrons in the its valence shell. Carbon has 4 electrons. Carbon has 4 electrons in its valence shell. Okay. 2s2 2p2. Therefore it forms 4 covalent single bonds. 4 forms 4 covalent single bond. Okay. To complete its octet, single bonds to complete its octet. Complete its octet. Okay, complete its octet. Okay. Hence, carbon has maximum covalency equal to 4 because it does not contain d orbitals. Hence, carbon has maximum covalency has maximum covalency equals to 4 equal to 4 because it does not contain d orbital contain d orbital. Maximum covalency of carbon is 4. Maximum covalency of carbon is 4. For the other it is 6. Carbon has 4 electrons in its valence shell, 2s square 2p2, and therefore it forms a 4 covalent single bond to complete its octet. Hence, carbon has maximum covalency equal to 4 because it does not contain d orbitals. Okay. Second point. Being the first elements, carbon has a higher ionization energy. Being the first element, carbon has a higher ionization energy. Carbon has a higher ionization energy, which decreases and moving down the group, which decreases on moving down the group, okay, which decreases on moving down the group. Okay. Third point, carbon is more covalent and less metallic. Carbon is more covalent and less metallic. Okay. And fourth point, carbon differs from other elements in its unique ability to form p pi bond. Okay. Carbon differs from other elements. Carbon differs from other elements. In its unique ability to form. Unique ability to form p pi multiple bonds. P pi multiple bonds. Okay. Such as carbon double bond carbon triple bond carbon double bond oxygen, carbon double bond sulfur, and carbon triple bond nitrogen, etc. Okay. Okay, fifth point. Carbon is the most electronegativity element of the group 14. Carbon is the most electronegativity, most electronegative. Carbon is the most electronegative, carbon is the most electronegative elements. Carbon is the most electronegative element of the group 14. Element of the group 14 of the group 14. Carbon is the most electronegative element of the group 14 of the group 14. Its electronegativity value is its electronegativity its electronegativity values its electronegativity value is 2.5, which decreases is 2.5, which decreases 2.5, which decreases and moving down the group, unmoving down the group, unmoving down the group. 2.5 unmoving down the group. Okay, example silicon 1.8. As example silicon 1.8. Okay, 6 point. 6. It has low inert pair effect. It has low inert pair effect. It has low inert pair effect. Hence, it has a great tendency to form. Hence, it has a great tendency to form covalent compounds. Covalent compounds. 7. Carbon also differs from the others. Carbon also differs from the others. Carbon also differs from the others in its catenation property. In its catenation property, it has a tendency to form. It has a tendency to form long and ring chain compound. Compound. Okay, by self linking. Okay, self-linking. Okay, due to small size, high electronegativity, and absence of d orbitals, the first members of the group 14 carbon differs from the other members of the group in the following ways. First, maximum covalency of carbon is 4, for other it is 6. Carbon has 4 electrons in its valence shell, 2s2 and 2p2. Therefore, it forms 4 covalent single bonds to complete its octet. Hence, carbon has a maximum covalency equal to 4 because it does not contain d orbital. Being the first element, carbon has a higher ionization energy value which decreases on moving down the group. Carbon is more covalent and less metallic. Carbon differs from other elements. It is a unique ability to form p5 multiple bonds such as carbon double bond, carbon triple bond, carbon double bond oxygen, carbon double bond sulfur, and carbon triple bond nitrogen, etc. Carbon is the most electronegativity element of the group 14. Its electronegativity value is 2.5, which decreases and moving down the group. Example, silicon 1.8. It has a low inert pair effect, hence it has a great tendency to form covalent compounds. Carbon also differs from the others in its catenation property. It has a tendency to form long and ring chain compound by self-linkage. Okay? Thanks. Next is diagonal relationship between carbon and phosphorus. Diagonal relationship between carbon and phosphorus. Diagonal relationship between carbon and phosphorus. Okay? Diagonal relationship between carbon and phosphorus. Okay? Carbon shows diagonal relationship with phosphorus, which is a member of group 15. Which is a member of group 15. It differs in many of its properties from other members of its own group, but carbon shows some similarity with phosphorus due to diagonal relationship. Okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, phosphorus, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Okay. Carbon shows some similarity to phosphorus in following respect. Carbon shows some similarities to phosphorus in following respect. First, carbon and phosphorus both are non-metals. Carbon and phosphorus both are non-metal. Carbon and phosphorus both are non-metals. Okay. Second point. Both form covalent compounds like methane and phosphine. Both form covalent compounds. Both form covalent compound. Both forms covalent compound like methane and phosphine methane and phosphine. Okay. Third point. Carbon and phosphorus both form acidic oxides. Carbon and phosphorus both form acidic oxides such as carbon dioxide and phosphorus. Carbon dioxide and phosphorus trioxide. Okay. P4O6. Okay. And P4O8 phosphorus tetroxide. Phosphorus tetroxide. Phosphorus tetroxide. Okay. Carbon dioxide reacted with water and make H2CO3, carbonic acid, carbonic carbonic acid. Okay, okay. P P4O6 plus 6H2O. This is a phosphorus phosphorus trioxide, P4O6. Okay, phosphorus trioxide. Okay, then plus 6H2O, that is 4H3PO3, 4H3PO3. Okay, okay. Then this is the phosphorus acid. This is the phosphorus acid. This is phosphorus, phosphorus acid, phosphorus acid. Okay, and P4O8 plus. Sorry, this is P3. This is uh, P4O8 plus 6H2O, that make a 2H3PO3 plus 2H3PO4. That is phosphoric acid. That is phosphoric acid. Phosphoric phosphoric acid. This is phosphoric acid. Okay. Fourth point. Fourth point. Carbon and phosphorus both show allotropy. Carbon and phosphorus both show allotropy. Allo, allotropy, allotropy, allotropy. Carbon exists. Carbon exists. Carbon exists in two allotropic forms. Exist in two allotropic, two allotropic forms. Allotropic forms is that diamond and graphite. Is that diamond, diamond and graphite. Diamond and graphite. Diamond and graphite. Okay. Phosphorus occurs in white. Phosphorus occurs in white. Phosphorus occurs in white. Phosphorus occurs in white. Red, violet, red, violet, red, violet, and black forms, and black forms, black forms. Okay. Fifth point. Carbon and phosphorus both form compounds with organic radicals. Carbon and phosphorus both. Carbon and phosphorus both form compound with carbon and phosphorus both form compound with organic radicals. With organic radicals. As a example, alkyl and aryl. Is that alkyl and aryl. Okay. Sixth point. The hydrides and nitrides of carbon and phosphorus are covalent in nature. The hydrides and nitrides and the hydrides and nitrides of carbon and phosphorus. Carbon and phosphorus are covalent in nature. Phosphorus are covalent in nature. Okay. 7.7 point. Oxyacids oxyacids of carbon and phosphorus are stable. Okay. Then a diagonal relationship between carbon and phosphorus. Carbon shows some similarity to phosphorus in following respect. Carbon and phosphorus both are non-metals. Okay. Both form a covalent compound like methane and phosphate. Carbon and phosphorus both form acidic oxides such as carbon dioxide and phosphorus trioxide and phosphorus tetraoxides. Okay. Carbon and phosphorus both show allotropy. Carbon exists in two allotropic forms, is the diamond and graphite. Phosphorus occurs in white, red, violet, black and forms. Okay. Carbon and phosphorus both form compound with organic radicals, is that alkyl and aryl. The hydrides and nitrides of carbon and phosphorus are covalent in nature. Oxyacids of carbon and phosphorus are stable. Okay, next comparison of carbon and silicon. Comparison of carbon and silicon similarities. Okay, carbon and silicon are the typical elements of group 14. Carbon and silicon are the carbon and silicon are the typical elements of group 14. The first two elements resemble each other in many respects, but they also differ from each other in many respects. Okay, Okay. Then similarities. First point, the both occurs in nature abundantly. Carbon is the principal constituent. Carbon is the principal constituent of a plant and animal bodies. All rocks all rocks and minerals, clay and soil are built up to silica and silicates. Okay. Both occurs in nature abundantly. Carbon is the principal constituent of plant and animal bodies. All rocks and minerals, clay and soil are built up to silica and silicates. Okay. Second point, both carbon and silicon are typical nonmetals. Both carbon and silicon are typical nonmetals. Okay. Third point, both electronic configuration. Third point, the electronic configuration of both elements. The electronic configuration configuration, the electronic configuration of both the element of both the elements is NH2 NP NP2, hence both show tetravalency. Hence both show tetravalency. Both show tetravalency. Fourth point. Both carbon and silicon show allotropic forms. Fourth point. Both carbon and silicon show allotropic forms. Both carbon and silicon show allotropic forms. Silicon show allotropic forms. Okay. Both carbon and silicon show allotropic forms. 5 point. Carbon belongs to animals and vegetable kingdom, while silicon belongs to minerals kingdoms or important constituents. Carbon belongs to animal and vegetables. Carbon belongs to animal and vegetable. Animal and vegetable. Carbon belongs to animal and vegetable kingdom, while silicon belongs to mineral kingdoms. Minerals kingdoms. Okay. Minerals kingdoms. Okay. Silicon belongs to minerals kingdoms. Okay. Minerals kingdom as a important constituent. Okay. And seventh, sixth point. Point six. Point. Both form acidic oxide, carbon dioxide, and silicon dioxide. These oxides react with bases and give salt. Both forms carbon oxides. Both form acidic oxides. Both form acidic oxides. Both form acidic oxides. Carbon dioxide and silicon dioxide. Carbon dioxide and silicon dioxide. These oxides react with bases. These oxides react with bases. Oxides react with bases and give salt. Okay. Carbon dioxide plus sodium hydroxide. That is Na2CO3, sodium carbonate plus H2O. Okay. And silicon dioxide plus 2NaOH, sodium hydroxide, that is Na2SiO3 plus H2O. Okay. Seventh point. Point 7. Seventh point. Okay. Point 7. The hydrides of both the elements, the hydrides of both the elements, the hydrides of both the elements are prepared by the same method, okay? Al4C3 plus 12H2, that is 4Al OH whole thrice plus 3CH4. Mg2Si plus 4HCl2 2MgCl2 plus SiH4. The hydrides of both the elements are chlorals, are colorless, yes, and form oxide in burning air. Okay? CH4 plus 2O2. That is CO2 plus 2H2O. And SiH4 plus 2O2. That is SiO2 plus 2H2O. Okay? Comparison of carbon and silicon. Okay? Carbon and silicon are the typical elements of group 14. The first two elements resemble each other in many respects, but they also differ from each other to many respects. Okay? And similarity. Both occurs in nature abundantly. Carbon is the principal constituent of plant and animal bodies. All rocks and minerals, clay and soils are built up to silica and silicates. Both carbon and silicon are typical nonmetals. The electronic configuration of both the element is NH2 and P2, as both show tetravalency. Both carbon and silicon show allotropic forms. Carbon belongs to animal and vegetable kingdom, while silicon belongs to mineral kingdom as an important constituent. Both form acidic oxide CO2 and silicon dioxide SiO2. These oxides react with bases and give salt. Okay? The hydrides of both the elements are prepared by the same method. Okay? The hydrides of both the elements are prepared by the same methods. Okay? The hydrides of both the elements are prepared by the same method. The hydrides of both the elements are colorless gas and form oxide in burning air. Okay? Both form same type of hydrides. As example, point 9. Both form same type of hydrides. Both form same type of hydrides. Okay? Methane CH4, ethane C2H6, C3H for propane, C3H8, and butane C4H10. This is methane. Methane, or methane, ethane, propane, propane, and butane, butane. The examples of silicon: SiH4, silicomethane, silicomethane, silicomethane. Si2H6, silicoethane, silicoethane, silicoethane. SiH8, silicopropane, silicopropane, and Si4H10, silicobutane, silicobutane. Okay. 10 point. Both form same type of compounds. Both form same type of compounds. Okay. Carbon and silicon. Carbon and silicon. Carbon dioxide, silicon dioxide. H2CO3, H2SiO2, CH4, C2H6, SiH4, Si2H6, CCl4, SiCl4, COOH whole twice, SiOOH whole twice. Oxalic acid, silico-oxalic acid, silico-oxalic acid. Okay. CHCl3, CHBr3, CHI3, SiHCl3, SiHBr3, SiHI3. Okay. 11 point. Point 11. Point 11. At normal temperature, at normal temperature, both react with F2 and form tetrafluoride, okay. Carbon plus fluorine, that is CF4, Si plus 2F2, that is SiF4. Okay. At normal temperature, both react with phosphorus and fluorine and form tetrafluoride. Okay. Then carbon plus 2F2, CF4, Si2F2, SiF4. Okay. And next is dissimilarities. Dissimilarities. However, the compounds of carbon and silicon show considerable dissimilarities as well. For example, carbon, and this is silicon. This is silicon, carbon, and this is silicon. First point. Carbon is a black color solid. Carbon is a black color solid. Carbon is a black color solid. Silicon is a reddish brown color solid. Silicon is a reddish. Silicon is a reddish brown color. Reddish brown color solid. Reddish brown color solid. Second point. Does not melt. Carbon does not melt. And silicon melts at high temperature. Melts at a high temperature. Okay. Melt at high temperature. Third point. Maximum covalency is equal to 4. Maximum covalency is equal to 4. Maximum covalency is equal to 4. Maximum covalency is equal to 6. Maximum, third point. Maximum covalency is equal to 6. Equal to 6. Maximum covalency is equal to 6. SiF4 can form additive compounds. Example, additive compounds. SiF4 plus 2NH3, that is SiNH3 whole twice F4. Fourth point. Forms long chains. Carbon forms long chain. And fourth point of silicon, it does not form long chain. It does not forms long chain. Fifth point. It does not react with chlorine and bromine. It does not react with chlorine or bromine. It does not react with chlorine or bromine at 500 degrees Celsius. At 500 degrees Celsius, it reacts with chlorine and bromine, and forms SiCl4 and SiBr4. Sixth point. Carbon monoxide is known. Carbon monoxide CO is known, but silicon monoxide is unknown. SiO is unknown. Seventh point. Carbon dioxide is a gas and soluble Carbon dioxide is a gas and soluble soluble in water soluble in water but silicon dioxide is solid. Silicon dioxide is solid and insoluble in insoluble in water. Okay. And 8 point point 8 point 8 the hydrides of carbon the hydrides of carbon CH4 C2H6 etc are stable are stable 8 point SiH4 is hydrolyzed with AgNO3 okay. 9 point CCl4 is a stable liquid. CCl4 is a stable liquid and IX point. SiH4 is a hydrolyzed with SiCl4 is a easily hydrolyzed forming liquid. SiCl4 is easily hydrolyzed forming liquid 10 point it does not form complex compounds. It does not forms complex compounds. X point it forms complex compound. It forms complex compounds. Okay. 11 point some forms of carbon graphite are good conductor and silicon is bad conductor and silicon is bad conductor. Okay. Carbon is black color solid. Silicon is a reddish brown color solid. Carbon does not melt and silicon melts at high temperature. Maximum covalency of carbon is equal to 4 and maximum covalency of silicon is equal to 6. Okay. SiF4 can form additive compounds. Okay. SiF4 plus 2NH3 that is SiNH3 whole plus F4 and carbon forms long chain and silicon so not forms long chain and carbon not react with chlorine and bromine while silicon is react at 500 degrees Celsius temperature to chlorine and bromine and form SiCl4 silicon tetrachloride and silicon tetrabromide. Okay. Carbon monoxide is known but silicon monoxide is unknown. Carbon dioxide is a gas and soluble in water. Silicon dioxide is a solid and insoluble in water. the hydrides of carbon, methane, ethane, it is stable, but silicon SiH4 is that means silicomethane is hydrolyzed with silver nitrate, okay? So CCl4 is a stable liquid, but SiCl4 is easily hydrolyzed, forming liquid. It does not form complex compound, it forms complex compound. Some forms of carbon graphite are good conductor, but silicon is bad conductor, okay? General method of finding normal mode frequency. General method of finding normal mode frequency, okay? Consider a system of two coupled system pendulum of the same length coupled by a spring of stiffness S, then their equation of motion are equation of motion are double m double differentiate of x plus mg by l into x plus s minus y equal to 0. This is the equation number first, and m double differentiate of y plus mg by l into y minus s minus x minus y. This is x minus y equal to 0. This is the equation number second, okay? Where x and y are the displacement of the bobs, two pendulum respectively for their mean positions, okay? L is the length of each pendulum, m is the mass of each pendulum bobs. I proved this equation number first of previous, okay? Where x and y are the displacement of the bobs, are displacement of the bobs or displacement of the bobs of the two pendulums respectively from their mean position, and L is the length of each pendulum. L is the length of each pendulum, length of each pendulum, okay? Length of each pendulum, and m the mass of each pendulum, and m is the mass of each pendulum, okay? I proved that, okay? Now, when a coupled system oscillates in a single normal mode, each components of a system vibrates with the frequency of that mode. Therefore, supposing that the system of the coupled pendulum vibrates only in one of its normal mode, let the frequency be omega, then the solution of the show equation are x equal to a cos omega t and y equal to b cos omega t. Why? Now, when a coupled system oscillates in a single normal mode, each components of the system vibrate with the frequency of that mode. Therefore, supposing that the system of the coupled pendulum is vibrates only in one of its normal modes, let the frequency be omega, then solution of the above equation are x equal to a cos omega t and y equal to b cos omega t, okay? And where a and b are the displacement amplitude of x and y at frequency omega, where a and b are the displacement amplitude of x and y at the frequency, x and y at the frequency omega, okay? Double differentiate of x equal to minus a omega square cos omega t, and double differentiate of y equal to minus b omega square cos omega t, okay? Substituting a 1 and 2, we have substituting in first and second, substituting first and second, we have first and second, we have comparison between tin and lead. Both tin and lead are the members of group 14 due to presence in the same group. They resemble each other in many respects, but they also differ from each other in many respects. Okay? Similarities. What is the similarities between tin and lead? First point. Both are soft metal. Both are soft metal. Tin and lead are soft metal. Both are soft metals. Okay. Second point. Melting point of both the elements are lower. Melting point of both the elements. Melting point of both the elements. Both the elements are lower. Okay. Approximately, the melting point of tin is 232 degrees Celsius and lead is 327 degrees Celsius. Okay. And third point. Both show variable valency of 2 and 4. Both show variable valency. Both show variable valency of 2 and 4. Fourth point. Both form amphoteric oxide of type MO and MO2. Both form amphoteric oxide. Both form amphoteric oxide of type MO and MO2. MO and MO2 approximately tin monoxide, stainless monoxide plus sodium hydroxide. If stainless monoxide is reacted with sodium hydroxide, that make sodium steinite. That make Na2SnO2, sodium steinite. Sodium steinite plus water, H2O. And lead monoxide, PbO, is reacted with sodium hydroxide, that make sodium plumbite, Na2PbO2, sodium plumbite plus H2O water. Okay. And fifth point, similarities between tin and lead of fifth point. Okay. What is the fifth point of similarity between tin and lead? By passing H2S gas in aqueous solution of both the salts, their sulfides are precipitated. Okay. By passing H2S gas in aqueous solution, by passing H2S gas in aqueous solution of both the salt their sulfides of both the salts their sulfides their sulfides are are precipitated. Okay. 6 point. 6 point. Both form unstable tetrahydride like tin hydrate and lead tetrahydrate. Okay. Then both form unstable tetrahydride. Both form unstable tetrahydride tetra tetrahydride tetrahydride like stainless tetrahydride and lead tetrahydride. 7 point. Both form tetrachloride which are hydrolyzed. Both form tetrachloride both form tetrachloride which are hydrolyzed. Okay. And stainless tetrachloride is reacted with 4 molecules of water that make HNOH whole 4 plus HCl hydrochloric acid and PbCl4 plus 2H2O that make lead oxide PbO2 lead dioxide plus 4HCl hydrochloric acid. Okay. 8 point. Point 8. Both form organometallic compounds like both form organometallic compounds. Both form organometallic compounds like lead tetraethyl like lead tetraethyl. Okay. Lead tetraethyl Pb4C2H5 whole 4 tin tetraethyl tin tetraethyl HNC2H5 whole 4. Okay. This is the similarity between tin and lead. First point, both are soft metals. Second point, melting point of both elements are lower. Approximately the melting point of tin is 232 degrees Celsius and lead is 327 degrees Celsius. Both show variable valency of 2 and 4. Both form amphoteric oxide of type of MO and MO2 by passing H2S gas in aqueous solution of both the salts. Their sulfides are precipitated. 6 point. Both form unstable tetrahydride like stainless tetrahydride and lead tetrahydride. Both form tetrachloride which are hydrolyzed. And 8 point. Both form organometallic compounds like lead tetraethyl and tin tetraethyl. Okay. Dissimilarities. Next point, dissimilarities. Okay. Dissimilarities between tin and lead. Dissimilarities dissimilarities between tin and lead. First point. First point. Dissimilarities between tin and lead. First point. Tin is a white metal while lead is a blue-gray metal but have a silver value, white luster in the pure state. Okay? Tin is a white metal. Tin is a white metal. Is a white metal. Tin is a white metal. Okay? Tin is a white metal while lead is a while lead is a bluish gray metal. Bluish gray metal. Bluish gray metals. Okay? But has a silver white. But has a silver white. But has a silver white. Luster. White luster in pure state. Okay, second point. First point, tin is a white metal while lead is a bluish gray metal but has a silver white luster in pure state. Second point, tin does not affect with moist air while there is a deposition of oxide layer on lead. Tin does not affect with moist air. Tin does not affect with moist air. While there is a deposition of oxide layer on lead, of oxide air in lead. Okay? Tin does not affect with moist air while there is a deposition of oxide air in lead. Third point. Tin does not affect with moist air. Okay? Second point. Tin shows the property of allotrope, whereas lead does not show this type of properties. Tin shows the property of allotrope. Okay? Tin shows the property of allotrope, whereas lead does not show this type of properties. Whereas lead does not show this type of property. Okay? Fourth point. Tin form metastanic acid with nitric acid while lead form lead nitrate. Tin form metastanic acid with HNO3 nitric acid while lead forms lead nitrate. Lead forms lead nitrate. Okay? Stainless is reacted with nitric acid HNO3 that make H2SnO2 plus 4 nitrogen dioxide plus water H2O. and lead reacted with 4 molecules of nitric acid HNO3 that make lead PbNO3 whole twice plus 2 molecules of water plus nitrogen dioxide, okay? And next point 5 points, okay? Lead chloride PbCl2 is insoluble in dilute hydrochloric acid. Lead dichloride is insoluble in dilute hydrochloric acid. Insoluble in dilute HCl hydrochloric, while stainless chloride is soluble, okay? Stainless chloride is soluble and is hydrolyzed, okay? Hydrolyzed. Next point, 6 point. Point 6. Tin form two types of sulfide. Tin form two types of sulfide. Tin form two types of sulfide: stainless sulfide and stainless disulfide. Is that stainless sulfide SNS and stainless disulfide SnS2, while lead form only one type, only one type of sulfide, only one type of a sulfide, like PBS, okay, like PBS, okay. Next point, point 7. Next point. Stainless oxide is acidic acid, but lead oxide is an amphoteric oxide, okay. HNO is acidic acid, but PbO, lead monoxide, is an amphoteric oxide, okay. The acidic property being rather feeble, hence lead monoxide dissolve in alkalis, okay. 2 HNO plus 2 sodium hydroxide that make Na2SnO2 plus Sn plus H2O. Second point, lead monoxide is reacted with 2 molecules of sodium hydroxide that make Na2PbO2 plus H2O water. And third point, lead monoxide is reacted with 2 molecules of hydrochloric acid and that make PbCl2 plus H2O, okay. Then dissimilarities between tin and lead. Okay, tin is a white metals while lead is a bluish gray metals, but has a silver white luster in pure state. Tin does not affect with moist air, while there is a deposition of oxide air in lead. Tin shows the property of allotrope, whereas lead does not show this type of property. Tin forms metastanic acid which can nitric acid, while lead forms lead nitrate. And lead chloride is insoluble in a dilute hydrochloric, while stainless chloride is soluble and is hydrolyzed. Tin forms two types of sulfide, stainless sulfide and stainless disulfide, while lead forms only one type of sulfide like lead sulfide (PbS). SnO is acidic acid, but lead oxide is an amphoteric oxide. The acidic property being rather feeble, hence lead oxide dissolved in alkalis. Then dissimilarities and similarities is the many types of properties is indeed of the group 14 elements, and we will be next study about the elements of group 15 nitrogen family. Okay, nitrogen family. Thank you.